We're back again with this vintage, allegedly, high pressure sodium light. And I'm taking a second look at the ballast here that was shipped over. And I think that it's much clearer than it was before. It always is beneficial to go and look at something at a later time when you're not annoyed about it. So I think there's a couple things missing still, because this has these connection terminals on it, but there's no terminal block here, so some component is missing. But we have a complete ballast. We have a transformer, we have an igniter, and we have a capacitor. So everything that we need to ignite the bulb and run the bulb is here. So I think that this is wired right now for 240. Because we have it's a 240 on this wire. So I'm going to take this wire off of here because we're not going to use it in 240 configuration. So my speculation to begin, I think the power to the mains connects to here, and this would be our mains, common, ground, and high. So the power is going to come in here. And we need to connect this to the high side of the transformer, which in my case here we're going to use 120 for now. It's just going to be easiest. Yes, 240 would be more ideal, but we're going to do 120. So we have this wire here which says 120. This one says 240. This one says 208, and this one should be 227, 277. Yep, okay, that's 277. So all these three are inputs, and we're not going to use these right now anyways. So I'm just going to tie these together. We don't need those right now, so we'll take all these out of the picture and just ignore those for now. So let's go ahead and connect this to our high side. Okay. Let's go ahead and connect this, preferably without the wire breaking again, to the incoming high side, because I think that's where it's going to belong. Now I don't, there's still something a little fishy though, because we have to include the daylight sensor in this matter, and I would rather the daylight sensor be before everything on here, so that when it's off there's no power involved. But that might not be the way it's, oh, we actually have a schematic here. That's interesting. Okay, it's kind of hard to read because there's also like water stain or something on there. Okay, so that's that. So now we have our high side connected, and we have the common and everything here. With the capacitor. The capacitor is connected to the capacitor wire, so I think the capacitor is copacetic now, and the igniter appears to be copacetic as well. So we have the common wire, which is going to this set of commons here, and we have the X3 wire, which matches with the X3 wire coming out of the transformer, so that's good. And then we have this, which is cut, and this says lamp, and this says lamp, and this was clearly cut at some point. So this needs to go back to here, and you can see the wire is the same. Now the mystery starts to come into play because we have a cut wire here and a cut wire here, and I'd be willing to bet that these two wires here, this high and this common, went to something that interfaced with this, which we don't have anymore. So we're going to have to kind of rework this. I think if the bulb went here, if the bulb was connected to this, I think everything would work. But that doesn't give us our daylight sensor, which shouldn't be hard to tap in. I think that all we would have to do is, replace, I believe the way that these work is you get high and low mains, and then this gives you the high to the fixture to turn it on. So I think all we would have to do is put this in between here and here, I think. Let me do some more investigation here and I'll come back on the video when I can confirm that. My theorem was correct. So this, I need to take this off, and we need to connect this red wire. I'm just going to take this off because it's not serving any purpose anymore. This needs to go on with here. Needs to feed the mains into the transformer. And then this high side will connect to this input. And then the common, I would say we'll just add to here. So we're going to have to just slice everything off of here, I guess. I'm confident that this should work. I'm still fairly new to all these HID lights, so I'm still kind of learning it, but this makes electrical sense at least. Okay, so that's that. So now we have this debacle here. I guess this kind of doesn't really serve a purpose anymore. I mean, I could strip these back and use shrink tubing and put new leads on there. I'm not sure it really serves a purpose at this point though. I think, at least just for testing purposes, I guess it wouldn't make sense to even bother with it. I'll just take my, I'm just going to take my testing cord here, and I'm going to just connect my testing cord to it for now. And if I can confirm that this is going to work, then we'll get involved in that later, fixing that those leads on there. Okay, so this is the high side. I'm working a little too fast here because I'm undoing things that I did. We'll connect this to this daylight thing, and then take this off of here, and we'll connect this to the common of my testing leads. Instead. And so then all that's left now is we have to rejoin this with the bulb. I think that these leads originally went to the bulb. Why they're different now, I have no idea. But they are. So let's just cancel this out. Cancel this out and redo this, and then I think we'll have a functional lamp here, which will be a relief, because what a freak show this has been. Alright, that looks like that should be the correct fix-up. So this is irrelevant right now. I gotta get the bulb for this, and then I'll put it in and we'll be back on the video. Alright, I think we're good. Moment of truth. Beautiful. It works. What a relief. Glad I got that figured out. So now we can finally see this light in its true glory with the high pressure sodium bulb. Seems like it's taken a long time to get brighter. There it goes. Just took a minute for the sodium to burn off, or the mercury to burn off, or vaporize. Now it's got that beautiful orange glow to it. It's running a lot of power though. Or is it? No, that's on amps. 54 watts. That seems copacetic as it warms up. This is a really cool lamp post. Those are too hot. I gotta finish that wiring so I can turn those off. I can't turn them off without losing that outlet. Should be getting closer to full. It's only at 55 watts. It's kind of low. It should be closer to 80. It's definitely the right, clearly says that it's 70 watts, so it should be fine. It's going up a little bit. I'll let it sit for a little while and see if the brightness gets brighter. I've had this running for about an hour now, just to make sure everything is copacetic, and it seems to be. It's up to full brightness now, and the power draw is at 73 watts, which is right where it should be. 0.84 amps with a power factor of 0.72. So that's all perfectly reasonable. And you can see that nice orange glow casting onto all the walls. Pretty neat. So I'm glad that this saga is over, and I was able to figure that out. It really is quite clear to me now. I guess I was just so annoyed by it when I was looking at it the first time that it seemed confusing, but now that I've kind of gotten over it, it's clear. So that's it for this one. This is operational. You know, another thing I like about it is that the way it refracts, it's very to look at, it's very pleasant. It's not blinding at all. It diffuses the light very nicely, so this will really become a nice aesthetics piece out in the yard. Not sure when I'll get around to putting this up. That might be a spring project, more likely, because it's going to be kind of involved, because I'm going to have to dig a trench and run wiring and dig a hole and put a post in and all that stuff. But this will definitely make it out in the yard at some point this summer, if not sooner.